everyone, welcome back to another video in our second unit on EDA. In this video, the title is Getting Integer Locations of Columns, and we're going to be revisiting a problem that we talked about a couple videos ago. So I have pandas imported, and again, we're going to be working with the taxis data. So I have here just the first 5 rows displayed. We can remind ourselves what this data looks like. And you might remember, I think this was in the video where we introduced indexing, or maybe it was a video a little bit after that. But we had wanted to know, well, what's the integer position of, I think it was the pickup burrow column. And the way that we had done it in that video is I said, well, df.columns. So I look at the columns attribute and I said, okay, we're just going to count. I'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we said, okay, pickup burrow is index 12. And then we used it with iloc. So that's fine, but it's not very Pythonic. It's not done in a very efficient way. You can imagine if there were hundreds of columns, well, how would I do that? So kind of that's the point of this video, to show a couple different ways of solving the same problem. Now, right off the bat, we can see here this df.columns. This maybe looks a little bit like a list, but it's actually a pandas index object. And the way we can check that is by saying type df.columns. And we can see here, this is a pandas index object. So for Math 10, I don't expect you to get too familiar with this object. Definitely data frame and series are the most important for us. But the point is that it's an index, it's not a list. So the kind of first exercise I have here is we're going to answer the same question, but we're going to use the indexed method of a list object. So notice here, this is index, it's a method of list. It's different from this index object. So what we're going to do is we're going to first define a list to be to represent the columns. So I'm going to take df.columns and cast it to a list. Then we can take a look at it. So this is looking good so far. If we wanted to just double check, we could say, well, what's the type of my list? And we can see it's a list, so that's good. And now what we want to do is just use the index method of list. So the way that works is I say mylist.index. And now I want pickup burrow. And it's saying 12. So that's the same 12 we got from counting. So remember we had 0, 1, 2, blah, 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 and counted to 12. So here's how we could do that without, actually counting it. Again, if this was position like 100 plus, this would be a lot handier. So that's one way. We cast it to a list and then we use the index method. Another way we could do it is by using a Boolean or getting a Boolean array and then using np.non-zero. So let's start by importing numpy as np. Then what I can do is I can say, well, let's take df.columns and let's ask, where is this equal to pickup underscore burrow? And we should get true in exactly one place, right? Because there's exactly one column named pickup burrow. And then what we could do is we could say np.non-zero and call this Boolean array. So I'm just going to copy paste it here as an argument. Now, one thing to notice here, so it's telling us 12, so that's good. But this is returning a tuple, and it's a length 1 tuple. And maybe that's a little bit strange. It's just something to keep in mind if I wanted to maybe extract this number. So I'll copy paste it. I could do here like 0 to get the 0th element of the tuple. And it's telling me this is an array with just one element, 12. So then if I wanted to get the 12, well, I could say give me the 0th element, and there's the 12th. So maybe a little bit cumbersome. Again, if we were just reading off the number, that'd be fine. But if I needed a way of actually coding it, maybe this would be a little bit more cumbersome. So next, maybe before we do this exercise, some of you who were in Math 9 last summer session will be familiar with np.where. So this has more functionality than np.non-zero. So what I do here is I say df.columns, and again, I'm going to ask, where is this equal to pickup burrow? And if I just do it like this, it returns kind of exactly the same thing as what I got from np.non-zero. But the nice thing about this is I can specify what to do if it's true and what to do if it's false. And what I mean by that is, remember we have a whole bunch of columns. Let's specify if it is equal to pickup Burrow, let's call this Peter. And if it's not equal to pickup Burrow, let's fill it with Anteater. So what this is going to do is it's going to put Anteater everywhere except for where it was equal to pickup Burrow in the original. So this was a silly example, but I just wanted to show you how np.where has more functionality. I can replace true values and false values with what I passed here. Last two kind of strategies. So the credit for these comes from Bing Chat. So I was reading through lecture notes posted by Christopher Davis for this class in preparation for this video, and he had gotten these ideas from Bing Chat, so that's why the credit is here. And it's saying, use the getLock method of a pandas index object, and this should be capitalized. Same thing for the other one. So, okay, let's do it. The way this works is, okay, so I need a pandas index object. So I can do df.columns, remember that's our index object. And then I can say .get_lock. And here I want pickup Burrow. So this is great, this is exactly what we wanted. The last one I want to show you, so this one's kind of has even more functionality than getLock. So what this does is, again, I'm going to say df.columns.get_indexer. And then what I can do is I can pass it a list of the columns that I want indices for. So let's say I want pickup Burrow. And let's say, so maybe as a reminder, let's see what df.columns looks like. So maybe I want pickup Burrow and also, I don't know, let's do drop off. So notice I pass it a list of the two columns I want. It's telling me that's index 12 and index 1. So kind of getting these two indices for these two columns is super easy using this getIndexer method. If we had wanted to do the same thing with any of the previous strategies that we had used, it would have been a lot more complicated and more difficult. So this getIndexer is pretty cool. And again, thanks to Bing Chat for letting us know about it. All right, I think this is a good place to end the video. Thanks for watching, and I'll see you in the next one.